Which of the following does not represent 2,3-dimethylheptane? Heptane tells us what our parent chain is. It tells us that our parent chain has 7 carbon atoms. And then the 2,3-dimethyl tells us about the substituents that we have on that parent chain. So this systematic way of naming a compound allows us to identify a molecule even as being the same as another molecule, even if it doesn't quite look the same from the drawing. So I think the first thing that we should do with all of these options is to find the longest carbon chain and to number it. So for the very first one, the Newman projection, we have to understand that within this Newman projection, we have 2 carbon atoms. So we have this front carbon atom, which is represented by that dot. And so that front carbon atom has a bond to a CH3, another CH3, and 1 hydrogen. So when we're counting our longest chain, we're not going to start from here. We'll count from one of those CH3 groups. And then the 4th bond to this carbon is to the carbon right behind it. And so that back carbon atom is represented by the circle. And so that back carbon atom is bonded to the front one, and then it also has bonds to a hydrogen, a CH3, and the rest of the carbon chain. So that circle is representing the back carbon atom. And so if we are to number this chain, we want to start at one of these 2 methyl groups. It doesn't matter which one, just we want to start at the terminal end of the chain so we get the longest carbon chain. So we have 1. This front carbon atom would be carbon 2. The back carbon atom would be carbon 3. And then the longest chain would be if we go this way. If we go here, we get a 4 carbon atom chain. There's just a methyl group. So we're going to count out this longest chain. So 1, 2, the back carbon is 3, 4, 5, 6, 7. So we do have a 7 carbon atom chain. And if we look at carbon 2, we have a methyl group. So that's your 2-methyl. And carbon 3 is the back carbon, and we also have a methyl group there, so 3-methyl. And since it's 7 carbon atoms, it is a heptane. So that does represent 2,3-dimethylheptane. And so let's move on to the next option. And it looks like our longest carbon chain is here, and we would hit our first substituents if we count from here or here. Either way is equivalent. So 1, 2, 3, 4, 5, 6, 7. So we have a 7 carbon atom chain again, a methyl and a methyl. So we have that 2,3-dimethyl. And it is a heptane. So this is also 2,3-dimethylheptane. So if we move on to C, 1, 2, 3, 4, 5, 6. So now we don't have a 7 carbon atom chain. So this is the option that doesn't represent 2,3-dimethylheptane. But let's just keep going and actually name this for extra practice. So we still have some methyl groups, 1, 2, 3 of them. So trimethyl, and they are on carbon 2, 3, 4. So this would be 2, 3, 4 trimethyl. And a 6 carbon atom chain means that this is a heptane, a hexane. So hexane, not heptane. So this is the one that does not represent the same molecule, which means that if I go to D and I number the chain starting either here or here, 5, 6, 7. So this is also a heptane, and we also have 2,3-dimethyl. So this is also 2,3-dimethylheptane.